My name's Karen Bibb, and I work in the aerothermodynamics branch at Langley. I grew up on the Space Coast of Florida, so I grew up watching space shuttle launches all my life. I grew up sailing on the water there. I went to this international science fair when I was in high school, and my project was actually sail design, and I got to do wind tunnel testing in high school. And I went off to college and studied aerospace engineering. Kind of came naturally just to end up at Langley. These days I'm actually working on the hypersonic aerodynamics for the Orion crew module, how the vehicle flies as it comes back in the atmosphere. As a team, we do wind tunnel tests and computational simulations to determine the basic forces and moments acting on the vehicle, the lift and the drag. And then I put all that data together to build a database so that the guidance and control systems can know how the vehicle is going to fly from the time it enters the atmosphere till when it lands. And one of the most exciting things in my career is in another week, we're going to see the test flight for this vehicle. The vehicle is going to go around the Earth a couple times, and when it re-enters, it's going to be flying the aerodynamics that I've helped develop over the last several years, and hopefully it lands in the right spot. So another thing I worked on that I'm very proud of is the work that I did with the Columbia accident investigation. The first thing we all did was sit around and figure out, well, look at all the different scenarios of what could have caused the accident. And I had a computational model of the space shuttle and was able to very quickly change the geometry so that a chunk of the wing leading edge was taken out. And when we ran those simulations and looked at the results, it was very clear that a jet of air could come up through that gap in the wing leading edge and hit the rear sensors on the OMS pod. The guys that were working the wind tunnel test models, they went back to the wind tunnel, cut a notch out of the wing leading edge, and were able to see that same increase in heating. Having the pressure of having to figure out what happened in the accident really pushed our capabilities a whole lot. And so now we've been able to use those capabilities for designing the Orion capsule. We're doing that in a much more efficient way. When I first started working here, it was early on in the days of the Americans with Disabilities Act. I got here and I realized that, wow, the building I was working in was not really wheelchair accessible. Just getting from my office to the cafeteria, I had to go in the street a lot because there weren't enough, the curb cuts weren't right. They just didn't have a lot of people on the center that needed those accommodations. And so, I kind of showed up, was young with lots of energy, and I think young people have so much more energy about anything. They're just much more willing to keep poking until it's right. Being a little bit different in this position could be seen as a barrier, and at the time, I've never thought of it that way. Looking back, I can see that maybe some of those people helping me were helping me a little extra because they wanted to see a woman succeed in this or something like that. But at the time, I just was focused on what I wanted to do and doing it, and not worrying about whether I was not the normal kind of person that went into this field or anything. It was fascinating to me, so I went after it. Find something that interests you, and when you get excited about something, keep pursuing it. Don't just let it go. And when other folks see that you're interested in something, and people see that spark of excitement in you, they're still willing to help. Whenever I seem to need some help from somebody, an adult, a mentor would just be there. People that are in their career and deep into it. When you see a kid that really wants to do something, help them. Do whatever you can to guide them on that path. Everybody's got challenges. With me, the challenges are kind of obvious, right? And to be able to understand that you don't have to see other people's challenges to know that they're there is, I think, a big thing. So I've been at NASA for almost 23 years. The best part has always been the people that you're working with. And the people here seem to want to do the work, and they want to focus on the really fascinating problems. I don't know what the future is going to be for my job at NASA. I'll continue working on Orion for the next few years. As long as I'm fascinated with the work as I am right now, I think everything's going to be here for a long time.